This will be an overview on how to conduct hierarchical multiple linear regression with SPSS. I want to make sure that everybody knows that I have already created a random sample using the filter variable. I split the data set in half because, as consistent with everything else we're doing with multiple regression and with all other statistical procedures, I think it's very critical that we make every effort that we can to validate our results. So in this case, we're going to run two separate hierarchical regression runs to test the consistency of our results, the replicability of our results. For this particular hierarchical multiple regression, what we are trying to do is we are trying to see if we can explain standardized science scores. And we're trying to see if we can explain science scores by, first of all, looking at the effects of reading and math scores, seeing how much variance in science scores those two standardized test variables account for. And then we're going to see to what extent beyond that socioeconomic status and race account for additional variance. And after accounting for socioeconomic status and race, then we're going to see to what extent gender matters above and beyond the effects of everything else we've included. So we would conduct this type of multiple regression, this type of hierarchical multiple regression, if we were interested in determining whether or not race and socioeconomic status has a unique effect above what we would get from our standardized test results and how much of an effect that was, and also whether or not gender has an independent and unique effect that is statistically significant beyond that which we would get from reading and math and SES and race. So to do this, we're going to go to Analyze, General Linear Model, Regression, Linear, and our dependent variable, the thing that we are going to try to explain, is science scores. And in our first block, we're going to enter standardized reading scores and standardized math scores. We're going to run this initially on our block that we're going to apply the rule of that's the value of 0, because we're going to do this same analysis twice. We go to statistics and we enter the variables that we would typically enter, but we need to make sure in this case that we're also asking for R-squared change, and we'll ask for the usual other variables that we would ask for, along with our analysis of the residuals. We go to plots and we ask for our usual plots as well. Now we're not going to be looking at these for the purpose of this video, but I want everybody to be in the habit of checking for all of this information. We then click OK. And we scroll down here and we see that this first block, where we've entered reading and math scores, we are accounting for, our R-squared is about 0.39, so we're accounting for about 39% of the variance already in science scores by our knowledge of reading and math scores. We're now going to add, we're going to go back and we're going to add in our socioeconomic status and race variables. But because both socioeconomic status and race are categorical variables, we've had to create dummy variables for them. I have not taken our time to do that, but I have created them previously. And you can see that they're listed here. So in terms of race, it will be comparing African Americans, Hispanics, and Asians to whites. And in terms of socioeconomic status, it will compare mid-SES, and high SES to low SES. So we are now going to go to our next block. Okay, so what we do with hierarchical regression is we add variables into the equation in blocks. So we go to the next block, and this is where we're going to enter all of our dummy variables for socioeconomic status and race. So our dummy variables for race are going to be Hispanic, Asian, and African American. And our dummy variables for socioeconomic status will be middle SES and high SES. Everything else stays the same, and we click OK. Okay, so we then scroll down, and we see now that we have more variables in our equation. And here's our new R square. It's gone from 0.39 to 0.473. That change is statistically significant. The amount of R squared change is 0.083 or 8.3%, which is what we would get if we subtracted 0.39 from 0.473. We would get 0.083. And again, the addition of those variables is statistically significant. So that block of race and ethnicity adds to our predictive ability or explanatory ability regarding science scores. We can look at the results to see what ends up being significant here. So what we see is there is a significant difference when we look at, so again, this is comparing the racial groups to whites. We see that there is a non-significant difference for Hispanics or Asians, but there is for African Americans. And in terms of socioeconomic status, we see that there's not really a significant difference between mid-SES and low SES, but there is between high SES and low SES. And we can see that that our math score is still statistically significant, but our reading score isn't. We have one more block to analyze. So we go back up to Analyze. And in this case, what we're going to do is we're just going to be trying to figure out whether or not, after we have everything else into our equation, whether or not gender has a significant effect on science scores. After everything else has already been considered, does gender make a unique contribution? So we're going to go to our third level, block 3 of 3, and we're going to put in gender. In this case, it's called female. We put it in there. Everything else is going to stay the same, and we're going to click OK. It will jump up our results, and what we will be looking for is whether or not we have a significant change. And what we see in this case is when we add gender, there is not a significant difference. So we have gone from an R square of 0.473 to an R square of 0.474, so a very tiny gain. When we look at our adjusted R square, which is our R square that is adjusted for our ability to estimate the population, you see that adding gender, we actually lose some distance, and that's primarily because of its effect on our degrees of freedom. So we know that adding gender does not make a significant input. We can see if, when we look down at our results, with everything forced into that equation, we have gender in here, we can see that gender is not statistically significant. But when everything is in the equation, our significant predictors are essentially math scores and whether the individual is African American compared to white. All other variables do not hit our 0.05 criterion. What we would now do is we would see to what extent, when we ran these models, the same thing here. We would run it again, all 3 steps with changing this filter variable. So we're going to change that to a 1, and we would go through the entire step, each step running that same analysis, and that would allow us to compare our results between the initial group, which is 50% of the sample, and our validation group. If the model is stable, if our results are stable, we would find that our first block was significant, our second block was significant, but females do not add significantly to the prediction or explanatory power beyond what was attributed to achievement scores, race, and socioeconomic status.